In this video, we're going to talk about looping logic structures. So we're going to continue working on our scenario, and we've made a whole lot of progress. All the things in green are tasks that we've completed. We've also worked on some refinements. In particular, last time we made the suit symbols and we made the face cards look more like face cards. You did that for homework. So we still do have some outstanding questions, though. One of them is what to do with the value 1. So I don't know if you realize this, but because we're using ace high, there is a chance that we could get the value of 1 coming out of our randomizer. And what do we do if that happens? Because that's not actually a valid value. So this is where the idea of data validation, which I've mentioned a few times, but this is where it really comes into play. So here we have a case where there is a possible value we could get for a variable that would be possible, but not valid, given the real life circumstance that we're trying to mimic. So what do we do with that? We could just create a little if error checking thing that says if randomizer returns 1, then we just change it to 2. I don't like that solution, because then what that means is mathematically you'd have a slightly greater chance of the number 2 coming up than any of the other numbers. And honestly, that's not what I want. I really want it to be as random as possible. I don't want there to be essentially extra 2s in the deck. So instead, what I want to do is check for the number 1 and then reject that value, reject it and just try again, draw another card, just start over. So that's what I want to do. I want to make sure that we don't get 1s, and if we do get a 1, just go back and try again. So we need to do some code for that, and that's a great application for a looping structure. I also would like to continue working on that idea of making the cards look more like cards, and we can use a looping structure for that as well. Then finally, we have a couple of problems that we created. When we made our cards look more like cards and we changed the face cards into letters instead of numbers, it created a problem with the scoring, basically. So we sort of broke the scoring. And I'm deliberately showing you how this, fixing one issue or improving one thing can actually break something else that you're doing. I purposely want to show that because that happens in coding all the time. And I want to show you how to troubleshoot that and keep moving forward, instead of saying like, oh, well, I better not do that great new thing I did because it broke something else. That's okay. Things are going to break. What you want to do is figure out how to troubleshoot and fix and keep moving forward, rather than just stopping and not allowing your development to be the best it can be. Those are the issues that we're going to deal with. Because these last two actually have more to do with branching structures and looping structures, I'm just going to show you some the finished code, and I'll just kind of talk it through. But with the what to do with the number 1 and getting the suit symbols elsewhere on the card, I'll show you how to do those, because those are both looping. So let's go ahead and do some coding. Okay, so here we are back in our program, and you can see I've continued to work on the CSS look of it, giving it that fancy header. I got rid of the junk since we didn't need that anymore. Let's go ahead and see how it's working right now. So it's working like so basically I took apart the place where you have the suit versus the value. What I would like to do is get another copy of the suit down here, like it would be on a real playing card. And this I love. I think that the symbols came out just great. Let's see if we can see some more. Yeah, I love the symbols. I think that turned out just great, but it really has hosed our scoring. Like there's no two ways about it. So we definitely will fix that. But I think it looks really cool. So I don't want to lose this. But I do want to fix the problem, because of course it's a problem. So let me just show you what I did here. So in order to break this up, I put a few paragraphs in our card divs, right? And I, put some CSS on those so that one of the top one goes to the left, the bottom one is going to go to the right. I have IDs on all of these so that I can target them for values. And notice I was very careful in my naming so that the name of the suit ones are the same, except for one character that I've added to the end of the name of that ID. Okay, and I did that deliberately because then that's going to help me when I code in order to easily put that suit in both places. Okay, now I've had to change get card as a result, obviously, because if I want to break it up, I'm not just placing one single thing. So I need to know whose card it is. That's the whole card, and that's so that I can apply the color, the red or the black. Then I need to know whose suit, and that's putting the symbol up here. Then I need to know whose value, and that's putting the value in the center here. So let's first deal with the problem with the number 1. That's a nice looping issue that we can deal with, and then we can be sure that we're getting all the right values that we want. We probably want to code that in right around here, right around where we're actually getting that value. So this is where we're sending that off to randomizer. And as I said, there is a non-trivial, minimal but non-trivial chance we could get a 1. So what I want to do, again, like I said, I don't want to just do the if, I want to eliminate 1 if it comes through as a value. So we're going to use a while loop for that. And we're going to say while card is equal to, and remember the double equal for equal to 1, the value 1, then we want to do stuff. And the thing we want to do basically is pick another card. And remember what I said about looping, you want to make sure that you do something that's going to trigger a change in the thing you're evaluating, or else you will never get out of the loop, right? So if card is equal to 1, I have to have some line of code within my while statement that's going to change the value of card so that it can evaluate it again, and at some point it will be non-1 and it can kick out of this code. Okay, so that actually should fix the problem. That should be all that we need. The thing is, how do we test that this is actually working, given that it's a random number, and how long are we going to wait before it actually has that slim chance of getting a 1? Well, we don't actually have to wait that long. What we can do is just comment out that line for the moment, set card explicitly equal to 1, and then we can put a little alert in here just to make sure that it is coming here to do its thing, and that it is coming back out again. Right? So we should just get the 1 alert, and then it should pop back out unless it actually draws a 1, in which case it should go until it isn't 1 anymore. Let's check this out and see if it is working. Yep. And there's another one, and there we go. So that definitely is fixing it for us if that ever comes up with a 1 value. So now we can get rid of this, get rid of that, and get rid of the alert, and we should be good to go. Okay, now the other thing we want to do, like I said, I would like to get the suit symbol down in this other place, which is called same exact name but with a 2 on the end. So since it has the same name but with a 2 on the end, we can do something a little bit crafty here, and maybe more complex than we would need. But I want to show you how to do a for statement, which is another type of looping structure. So for statements, unlike while statements, have a terminal condition, which sounds very deadly, but it's really fine. Now, for statements, these are common to any compiled language. They go far, far back in the history of programming. They're one of the first things. Ifs and fors were one of the first types of logical things. That was sort of the original branching was if, and the original looping was for. The typical variable that's used in a for statement is I for increment, and being an old-time programmer, I always use I unless I have a nested for, in which case I might have an I and a J and a K. You don't have to be constrained by that. You can use any variable you want, but for me, it's got to be I. So the first thing you do in a for is initialize your variable. So notice I didn't say var I at the top of that or anything, and I don't have to, because I'm going to initialize it right here in my for statement. So for I equals 0, that just initializes the variable. And as long as I is less than or equal to 1, because we just want this to do it twice, which is why maybe using a looping structure is a bit of overkill here when we're only doing it twice, but still, it'll illustrate the principle. And then I want I to increment by 1 each time. So that's I++, remember that's the incrementer. So it's basically what's going to happen, and then let me get my squiggle brackets going here. And we want that line of code in the squiggle bracket, but then we're going to have to write a little bit more too, or else we're just going to write that same club or heart or spade or whatever twice in the same place, and that's not what we want. Okay, so here's what happens here. It starts at I equals 0. It does the thing that it's supposed to do. When it gets to the end, it increments I. So now I is going to equal 1. So it's going to go through it one more time. It'll increment I again. And then I, the third time around, will equal 2. And when I equals 2 and it hits this condition, it's going to say, oh, you've already hit your terminal condition. And it'll kick out and go to the next line of code, which will be this one. Okay, so this will do it twice. We could make this, though, anything we wanted. We could make this 100 and it would do it 100 times. But we don't want that. We want it just this couple of times for these two things. Now, What's the tricky thing that we want to do in order to make this fill in both of the suit designations there? So here, all we're going to do is take whose suit, which is our variable here that has the name of the place where that symbol needs to go. And we're going to set this equal to itself, which is one of the really beautiful things you can do with variables. You can set them equal to themselves, you know, and then change, right? Plus, and this is very important, to in quotation marks, because that means it's to the string, not to the number. And we want this to be to the string because it's the name of the place where the other one's going to go. Okay, so you see what's going to happen. It's going to put in this original symbol. Then it's going to add to the name, which is what we did up here, right? We added a character to the name. And so then it'll come back through this time with the new name with the 2 on it, and it will put the other one in the other spot, theoretically. And there you go. Super cool, right? So now it looks, these are really starting to look like playing cards. And that's great. And I love these. I think these turned out terrific. But they have totally broken our scoring mechanism. So let me just go ahead and show you how I fixed that. Let me just tell you why it's broken, right? So when we go to compare the cards, we were turning the string values that we were grabbing off the HTML page into numbers. Well, what do you think happens when you try to turn that into a number? You get one of those NaN, not a number errors. And we saw those when we were doing some of our coding in one of the other videos. So how do you compare a NaN to a 10, right? Like that doesn't make any sense. So what we really need to do is check if it is, you know, kicking out that error. We actually can use that to our advantage, and we can use that as a condition to then go detect when it is not coming back as a number and then fix that issue. So that's essentially, and again, this is like on those cooking shows where they show you the whole recipe and then they go to the oven and they take one out that's completely finished. So I'm kind of doing that with these last 2 bits that I'm going to talk about here, just because, like I said, this really goes back to branching rather than looping. But I just wanted you to know this process of fixing a thing that you broke by doing something else. So I actually am using a function called isNaN, and it just returns a true or false based on whether or not it's getting the NaN error. So what this is saying is, if isNaN, basically, if that comes back as true, then do this thing. Otherwise, we just are going to convert that string to a number like we originally did. Now, the thing that it's going to do is a new function that I wrote, and that it's doing the same thing here with the computer number and the user number. So the function that I wrote is val2num, and that's just going to unconvert our face cards that we converted to those strings. Now, the one feature that I did want to show you, just like I wanted to show you the isNaN function, the feature that I wanted to show you here, so we know that the card value that I'm sending, because we got an isNaN error, we know it's a string, right? So I'm sending a string, and we know that the last digit, the last character of that string is a K or an A or a Q or a whatever, right? And that's the thing we want to convert back into a number. That's the thing we want to throw into our switch and convert back into a number. But remember, we also have this symbol, and that could be a symbol, or it could be like that 5-character HTML code. We're not quite sure what is being sent through on that. What are we grabbing? You know, how is that coming back to us? We don't know. But what we do know is the last character is the one that we want. So we don't even have to care about the rest. We don't have to care about the length of the string. We don't have to care about whether it's sending this as a little crown or as a HTML code of 5 digits. We don't have to care about any of that. We know we can just grab the very last character, and you can do that by using a negative number in your slice. So a slice of -1 is going to start from the right, and we just need 1 character off the right. So that's why I did -1. And remember, if you don't put in the second parameter, the length parameter, it just returns the whole rest of the string. And in this case, the whole rest of the string is that 1 character. So I just kind of sliced off that last character. I threw it into a switch, turned it into a number, and that's the number that's being returned. So let's go ahead and check this out and see if it's working. Oh, great. So now we actually have winners again, And oh, this is a good example, an ace versus a 2, and you definitely win, shows that we're using an ace high system. And there's our queen, the computer does win, that's right. Ooh, and that is a tie, and the jack. Okay, so that is working pretty well. So we have accomplished most of the functionality that we envisioned in this. The last thing that we need to do is, if we want this to be a one deck game, then we actually do need to keep track of which cards are being played. So that's what we're going to tackle in our arrays and objects lesson. And in the meantime, we can play a game of war with the computer.